Sir Isaac Newton actually owned this book, and it was published 339 years ago today. Today, I'm in the Cambridge University Library, and I am more excited than I have possibly ever been whilst filming one of these videos, because what I'm looking at is Sir Isaac Newton's very own first edition annotated copy of Philosophiae Naturalis Principia Mathematica, more commonly known simply as Principia. Published on this day in 1687, this is the book that made Isaac Newton such a recognisable name, and it is, I think, one of the most important books in the history of science. It's in this book that Isaac Newton published his laws of motion and also his universal law of gravitation. So as I mentioned, this is actually Isaac Newton's annotated copy, so you can see lots of his annotations in the margins, but there's also bound between each page a blank page so that he could use this for his notes. Newton's law of universal gravitation says that any two particles of matter in the universe will be attracted to each other by a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. In other words, gravity is a pulling force, and you can work out the strength of that pulling force if you know the mass of the two objects and also how far apart they are. This law remained the most accurate gravitational theory until Einstein's general theory of relativity in 1915. Einstein's theory provided a more accurate and thorough way of making calculations related to gravity, but Newton's law still holds up pretty well in most cases, and it's also much simpler to calculate than Einstein's theory, and so it's still used pretty commonly today. We only start to run into issues with using Newton's law if we need to make a calculation which is extremely precise, or make a calculation about an object which is extremely heavy or moving at a very high speed. For example, Newton's law of universal gravitation doesn't work for predicting Mercury's orbit, or if you're trying to make any calculations relating to black holes. But this book doesn't just talk about the universal law of gravitation and the laws of motion. It's actually in this work that Newton first published some of his work on calculus. Although Newton doesn't actually explain any of his workings or theories around calculus in Principia, these came in a later publication, he uses these methods to underpin his work, and it was the first time that he had used these mathematical methods in a published work. So in one fell swoop, Newton published his work on three topics that you probably learned about in your school maths and physics classes: gravity, the laws of motion, and also calculus. There really aren't many books from the 17th century that you can say that about.